Hello and welcome to this live stream sponsored by Exponent to Success. So, my name is Vikas Sharma, and if you're a student of class 10th, this is the best experience that you're going to have. And in today's live stream, we are going to cover about quadratic polynomials. So we'll first go step by step about what a polynomial is, how to identify whether it's a polynomial or not, and then we'll see how to find what are quadratic polynomials in particular. So polynomials are of various types. So we'll understand the types of polynomials also, and then we'll understand what exactly are quadratic polynomials, and then how do we factor quadratic polynomials. So you sometimes have to factorize the polynomial and find out different factors, express the polynomial as a product of two factors. So we'll learn how to do that as well. And we are also going to find the roots of quadratic polynomials, or how to find the zeros. Roots are also called zeros. So how to find the zeros or the roots of a quadratic polynomial. And so this is going to be a very wonderful learning experience for you, especially if you are a student of class 10. And why I am saying that this is very important for your studies is because you know that 10th class you are going to appear in your board exams. This year CBSE has decided will be held in two sessions. So there is the first session, which will be held in October or November, and it will be an MCQ based session where most questions are going to be MCQ type questions. In fact, all the questions are going to be MCQ type questions. And the second exam, or the second session, you are going to have in March or April, and in those you will have subjective questions as well. Now the syllabus hasn't been released by CBSE as yet, so we don't exactly know as to what is coming in the November December session and what is coming in the March April session. So we'll prepare it both ways. I have kept a mix of questions which are both MCQ based questions as well as subjective questions. But even if it's MCQ based, you have to learn the process of how to factor the polynomials, or how to find the zeros of the polynomials. And we in this session we are also going to learn what is the relationship between the roots or the zeros of a quadratic polynomial to the coefficients of the x term, x square term, and the constant. So using those coefficients in mind, we will also learn what is the sum and product of the roots. So that is called the relationship of the roots of the polynomials with the coefficients. So everything is going to come in your board exams, and this is a very good preparation for you. Now let me tell you a little bit about my channel. My channel's name is Exponent to Success. So exponent, exponent is a power. So any number raised to a certain power, it exponentially grows. Exponential graph is always starts very slowly in the beginning, but suddenly there's a great increase. And that's what is going to happen in your learning curve as well, because that's my plan, that if you stick with me, if you continue to learn the important concepts. So in this year I'm going to cover everything related to the 10th class syllabus. And though I have already have quite a few videos uploaded and you can already watch them, so the best thing for you is to subscribe to the channel right now. If you haven't subscribed to it, so do subscribe to it, because subscribing to it will make sure that you will not only be able to see all the past videos that we have uploaded, but you will also be notified of any future videos that are going to be uploaded. And not but there is one minor thing that you have to do for that. Along with subscribing, there is a bell icon there. You have to click on the bell icon also, because YouTube has strange ways. Even if you subscribe, the channel may not be shown to you, or the video may not be shown to you. This change has recently come about in YouTube. So you have to click the bell notification and click on all buttons, so that you do get a notification whenever a video is released. Now, like I said, there are already quite a few videos uploaded, but whichever concepts are left, I'm going to upload during this year. And not only that, any particular problem that you have, you can post a comment in any of my videos, and I'll make sure that that I address your queries. I read all my comments. I respond to all my comments. So whenever you leave a comment in any of the videos, I'm surely going to read it and I'm going to respond to it. So probably I'll make a video for you if it's a concept which I think that hasn't been addressed in the past, and a lot of queries are coming in for that particular concept. Or if I'm not able to make a video, I will personally solve that problem for you. So make sure that you subscribe to the channel, and also do not forget to like the video, because liking, what happens is liking serves two purposes. So the first purpose is that when you like the video, it gives me a motivation that yes, I am doing it for you and you're showing your love back to me by liking the video. So you're liking what I'm doing. And obviously if you leave a comment, I'm going to like that also. Plus the second purpose that liking uh, uh, serves is that when you like a particular video, that video is also shown to your friends or people in your contact, so it is spread out to more people who have similar interests like you. So it will help you also and help me also, that your friends also become more knowledgeable about the concept. So that is about my channel. Now, the live stream that I'm doing, this is a part of the Study with Me series. So, Study with Me, I've kept a special name for it to differentiate it between just a video that is uploaded on the channel versus a live session like we are doing right now, where you are in front of me and I'm in front of you and I'm talking directly to you. So that is a live stream Study with Me series, and we are going to study together. But this is not going to be only studies, this is also going to be a lot of fun, and for that I need your help with that, because I cannot make it fun alone. It will happen to be fun only when you get involved in it. I want you to sit with a notebook and pen right now. So if you don't have a notebook and pen with you, go and pick up your notebook and pen, sit during the live stream. I'm going to share some questions that I've prepared, which I think are very important from the board exams point of view. So very important questions. Questions similar to those might come in the exam, and like I said, they are both going to be MCQ type questions as well as subjective questions. Plus, not only that, to make it even more interactive, I'm saying that if you have a doubt in any of the questions, so I'm sure you must have learned polynomials in school also. You must have practiced it at your home also. So in case you are having a doubt in any of the questions, do not forget to post it on the chat box right now, so that before the stream ends, I'm going to address the question for you. I'm going to solve the question for you so that you understand how those questions are done. Right. So that was about it. Now, these live streams that I do, they are held every Sunday at 5 p.m. Indian Standard Time. So if you happen to be in India, don't forget to log on to Exponent to Success, or there's another channel that I have by the name of Ganitavya. So I do these live streams alternative. So this week, if it is on Exponent to Success, next week it would be on Ganitavya, and the week after that back to Exponent to Success. Ganitavya is my Hindi channel, so all videos are there, uploaded there, are in the Hindi language. And Exponent to Success is my English channel, so all videos you'll find here will be in the English language. So do not forget to subscribe to Ganitavya also. So all you have to do is just go to YouTube, search for Ganitavya, you will reach that video. You will reach that channel, I mean, and do not forget to subscribe and click on the bell notification also. Right. So, like I said, today we are going to talk about quadratic polynomials. And quadratic polynomials, we learn how to factor them, how to find the roots and zeros of the polynomials, and what is the relationship between the roots and coefficients of the quadratic polynomial. So, let me start with the sheet that I have, the questions that I have prepared. So, quadratic polynomials, this is a part of chapter 2 of your book, which is polynomial. So polynomials, again, there are quadratic polynomials, and then after that you've got also cubic and biquadratic polynomials, which we'll cover in the next live stream. So this live stream is only limited to quadratic polynomials. Right. So do post in your questions whenever you have a doubt, or if one particular question that I am explaining you do not understand, that you do not get that, do send me a chat or send me a comment on the chat box, and I'll surely repeat the concept for you. So let us get into the first question, or before getting into the questions, let's address what are some of the concepts of quadratic polynomials. So if I talk about the concepts, we'll first going to talk about what are the different types of polynomials. So the different types of polynomials is there's a linear polynomial. So linear polynomial is always of the form ax plus b. Then there is a quadratic polynomial. Quadratic polynomial is of the form ax square plus bx plus c. This is the general form. Then there is a cubic polynomial. Cubic polynomial is of the form ax cube plus bx square plus cx plus d. And then there is a biquadratic polynomial, which, so biquadratic means it consists of two quadratic factors, biquadratic, or it is also called a quartic polynomial. Quartic polynomial, which is of the form ax to the power 4 plus bx cube plus cx square plus dx plus e. And finally, there's a constant polynomial. Constant doesn't have any variable in it. It's just a constant which is of the form a. So now this also brings us to the degree of polynomials. So polynomials are basically identified by the degree they have. So if I talk about a constant polynomial, there is no x term in it, or even if the x term is there, it is actually hidden. So this is actually of the form ax to the power 0, and x to the power 0 we know is 1, so that is why we write it only as a. So whenever it's a constant polynomial, the degree of the polynomial is 0. Whenever we are talking about a linear polynomial, we're looking at the highest power that the variable is taking, and the highest power here in this case is 1. So that is why it is called a linear polynomial. Whenever the degree is 1, it is called a linear polynomial. Quadratic polynomial in one is one in which the variable has got the highest power of 2. Like here we see it has a power of 2. So whenever the highest power is 2, it is called a quadratic polynomial. Cubic polynomial has the highest power of 3. It is also called that the degree of a cubic polynomial is 3. Quadratic biquadratic polynomial or a quartic polynomial is going to have a degree of 4, or the highest power of the variable is going to be 4. And then we come to the zeros of a polynomial. So let me change the color of the pen. Okay, I prefer to have white because I think when I write in red, it may not be very clearly visible to you. So in case you have any problems of visibility, or if you think that the stream is slow, so if the stream happens to be slow, or if you are seeing it blurred, all you have to do is click on the three dots or settings of the video and go and click on there's a button of quality given there. So quality is sometimes reduced and it comes down, because of which you are not able to see it very clearly. Just click on quality and choose the highest quality or a higher video quality, and then you will be able to see it better. Okay, so coming back to it, when I talk about the zeros of a polynomial, zeros are also called the roots of a polynomial, or roots. By roots I mean that value of the variable for which the polynomial happens to be 0. So for example, if ax square plus bx plus c, and we have to find the value of the variable, that value that we get at which this whole polynomial is equal to 0 is called the zero of a polynomial, or the root of a polynomial. So that is going to be this thing, those are zeros of a polynomial. We learn how to factor the polynomials and hence find the zeros of the polynomial. Why it is also called zero or roots is because if you look at a polynomial, if on the Cartesian plane, a quadratic polynomial will have a graph like this. So here you see it is intersecting the x-axis at 2 points. One point is this and the other point is this. So at these points the value of the whole polynomial becomes zero because it is exactly lying on the x-axis, and we know that the value of y is zero at both these points. So we are looking at these 2 points. Basically they are also called the x-intercepts. So in a linear polynomial we have a graph like a straight line, so it will intersect the x-axis at only one point. In a quadratic polynomial, it would intersect at 3 points, sorry, 2 points. In a cubic polynomial, it will sometimes go like this, where it intersects at 3 points, 1, 2, 3. And in a biquadratic or quadratic, it will intersect the x-axis at 4 points. So basically, at all those points at which the value of the polynomial becomes zero is called the zero of a polynomial or the roots of the polynomial. Now there's also a relationship between the coefficients and sum of product of zeros of a polynomial. So like I said, we are basically limiting ourselves to talking about only quadratic polynomials in this stream. So if I talk about the coefficients, normally, like if we have a polynomial like ax square plus bx plus c. Now, if we find the zeros and let's say that there are two zeros which are alpha and beta. So basically, you see, if you find the sum of the two roots, which is alpha plus beta, you'll notice that it is going to be minus b upon a, which means you take this term divided by this term and take the negative of that. That should be equal to the sum of the roots. And similarly, if you take the product of the roots, which is alpha beta, you'll find it is nothing but c upon a. So take c divided by a, and that will give you the product of the two roots. So using this relationship also, we can find out what the polynomial is, we can find out the roots of the polynomial, and we can do a number of things which we are going to learn in this stream. Now, like I said, I have chosen some questions. We are going to do that, but at the same time, I want it to be interactive. So if you have any questions in between, do not forget to leave it in the comment box so that I can have a look at that and explain how that question is done. So basically, let's go into the questions straight away. Wish you all the best. And one more thing, I also said that do sit with a notebook and pen. So the purpose of that is that while I am solving the question for you, before I solve it, you should be able to solve it before me. This is a multiple type question. So basically, you'll have to choose which one of the following is a polynomial. And so out of the four choices, only one of them is a polynomial, and you have to choose the correct answer. So especially multiple type and even in subjective, you do the calculations on your own, you solve the question on your own, and before I give you the answer, if you send a comment on the chat box, I'll be very happy to know that you already know the concept, and then I can skip those parts and move forward a little faster. So MCQ type questions, I'm sure you can do it before me. Just write the option number. So basically there are 4 bullet points. Take the options as A, B, C or D. So just choose the correct answer, type it in the chat box, and I will display the comments also whenever, as and when they come. Okay, so we have to choose which of the following is a polynomial. Like I said, a polynomial is basically identified by the degree it has, and by degree I mean the highest power that a variable has can have, or the variable has in that particular polynomial. Now there is one particular limitation to that, is that the power has to be an integral power, or a positive integral power. So it has to be, it can be 0, in which case it's a constant polynomial, but it has to be a positive integer. So anywhere where you see a negative integer as the power, or you see a fraction as a power, that cannot be the polynomial. So in this case, if we see the, and we are not looking only at the degree, we are going to look at all the coefficients of x. So if we look at this one, this has a power of 2, which is an integer. Here there is no power, but we know that the power is 1. So that also, had it been just this, it would have been polynomial. But if we look at the variable x here, it has a square root. So square root always has the power 1 upon 2. So 1 upon 2 power is a fraction. So as soon as a fraction comes, the variable is taking a fractional power or a negative power, we know that this is not a polynomial. Have I received any correct options? There is two people who have sent a comment. There is Rashmeet Huda, who says that it's the polynomial, uh, D is the correct answer, and there is also Naman Sharma. Welcome both of you to the stream, and let's see if D is indeed the correct answer or not. So let's look at the second one. So in the second one, we see that it has a fractional power. So again, here also we have a fractional power. So this is also not a polynomial. Here it is again a square root, so which means it has a power of 1 by 2, a fractional power. This is also not a polynomial. Here, if we look at the powers of the variable, x has got a power of 2. Here there is 3 root 3, so 3 root 3 is the coefficient, but x itself is outside the root, which means it has a power of 1, and there is no variable here. So 2 and 1 both are positive integers, so this indeed is a polynomial. Now, you must be getting confused here. One thing not to get confused is that the coefficient can be anything. It can be an irrational number, it can be a rational number, it can be a fraction, it can be a negative integer, it can be a positive integer, it can be anything. But the power of the variable should be a positive integer. Okay, so congratulations both Rashmeet and Naman. You have got the right answers. And let's move on to the next question that we have. Again, an MCQ type question. You have to choose which one of the following is not a polynomial. Four options are there, out of which only one is correct. Choose the correct answer. I am still waiting for who is going to give the correct answer first. And meanwhile, I'll tell you. Let us look at the degree. So we have got power of 2 here, power of 1 here. So this indeed is a polynomial. We've got a power of 2 here, we've got a power of 1 here, no x term in this, so this also is a polynomial. We've got a power of 1 here, and here the x comes in the denominator, which means we can also write it as x plus x to the power minus 1. So as soon as a negative power comes, we know that this is not a polynomial. Let's look at the last one also. So it has a degree of 3, which is the highest power. So 3 is a positive integer, 2 is a positive integer, here 1 is a positive integer. So obviously this also is a polynomial. So the correct option is option C. And again, Naman was the first one to answer. Congratulations, Naman. You've got the right answer. Let's move to the next question that we have, and we are going to go very quickly. So as I said, in case you also have any questions, do not forget to leave them in the chat box so that I can address those queries for you. This also is an MCQ based question. Now here you have to find the zeros of the polynomial. So they have given a polynomial to you, and you have to choose the correct answers as to what will be the zeros of this polynomial. So here we will have to find the roots, and roots can be found on two ways. But before I tell you about the how to find it using the sum and product or the relationship of roots and coefficients, let's try and factor this polynomial. So you know a quadratic polynomial is always written in the form ax square plus bx plus c. This is the general form of a quadratic polynomial. So all you have to do is you have to take the a, which is the coefficient of x square, and you have to take the c, the constant term, and multiply both of them. So a, in this case, let's write what a, b, and c are. So a is the coefficient of x square, which is 4. B is the coefficient of x, which is 5 root 2, and c is the constant term, which is going to be minus 3. So the sign also has to be included, so do not forget to include the sign also. So we have identified what A, B, and C are. So we are going to take A into C, the product of A into C. So 4 and 3, we are taking the absolute value. No need to take the negative sign when you're finding the product. So the product of these two is 12. So we have to find the factors of this. We have to express 12 as a product of two factors, such that then it is also important to look at this sign that we have. So this sign here is negative. Negative means we have to find two factors such that when we subtract those two factors, it should give us an answer equal to b. And if we do not, if we have got a plus sign here, then we need to find two factors, so that if we add those two factors, it should give us an answer equal to b. So in this case, because I see that b has got 5 root 2 in that, uh, okay, so 5 root 2, that means a root 2 has to be there in the factors. So 12 in that case can be written as, what can 12 be written as? It is actually 2 root 3 is 12, but 2 root 3, again I can write it as root 2 times root 6. So that is one product which will not work here, because we cannot add root 2 multiplied by root 6. Then, okay, sorry, root 2 into root 2 is 2, and then we have got root 3. So again, we cannot do this because it is not going to work. It is not going to give us a sum of 5 root 2. Then we are looking at the next term. So next is 12 can also be written as 6 into 2, 6, or it can also be written as 6 root 2 times root 2. And because we have got a negative sign here, that means if we find the difference between these two, 6 root 2 minus root 2, we are going to get 5 root 2, which is the b term. So that means these are the factors that we are looking for, 6 root 2 and root 2. So let's do the middle term splitting method and find out what the roots of the polynomial is. So then 5 root 2x can be written as, so if it's a positive 5 root 2x, that means the 6 root 2 has to be positive and the root 2 has to be negative. So we'll split it into 2. So we get 6 root 2x minus root 2x minus 3. And then taking something common in the first two terms, we get, we can take, I think, root 2. We can actually take 2 as common, 2x as common. So we are left with 2x in the first term, plus what are we left with? 3 root 2 in the second term. And in fact, we can not only 2, we can take 2 root 2 as common. So let me erase this. Erasing would be a better option, I think. Okay. Uh, so we are going to take, split it into 2. So we are going to take 2 root 2x as common. So in the first part, we are left with root 2x plus, here we have already taken root 2 as common. We have taken 2 as common. So only 3 is left. In the second case, there's nothing that we can take common, but we can take minus 1 as common. And inside the brackets, we'll be left with root 2x plus 3. Now again, in these two terms, we see that root 2x plus 3 is common. So we can say that root 2x plus 3 Taking that as common, we are left with 2 root 2x, and in the second term we are left with minus 1. So now if this is equal to 0, if the product of these two is equal to 0, that means either root 2x plus 3 equal to 0, or 2 root 2x minus 1 is equal to 0. And then we find the value of x. So 3 goes to the other side, that becomes minus 3. Root 2 will be divided by that. So we get 1 root as 1 0 as 3 minus 3 upon root 2. And the other one is that here 1 goes to the other side. So x will be equal to 1 upon 2 root 2. Now 2 root 2, what can we do in this? So basically we've got uh, uh, we've got a irrational number in the denominator. We'll have to rationalize the denominator also. So do not forget to rationalize whenever you have got an irrational number in the denominator. Multiply both the numerator and denominator by root 2. Here also multiply both the numerator and denominator by root 2. You get negative 3 root 2 over 2. That is one of the roots. Or x will take a value of root 2 upon root 2 into root 2 is 2, 2 and 2 is 4. So we have got these two factors, negative 3 root 2 upon 2 and root 2 upon 4. So this is the correct answer. Option C is the correct answer. No takers for this, so nobody has solved it as yet, so I can't show you the answers. But let's move on to the next question that we have. Now, this is a subjective type question, and I want you to solve it before I can continue with it. So before I tell you what the solution is, you have to solve it in your notebook and come up with the answer very, very quickly. So basically, the polynomial that we have is 6x squared minus 3 minus 7x, and we have to find the zeros of the polynomial and also verify the relationship. I'll teach you how to do that, but try and do it on your own first. So like I said, a polynomial, a quadratic polynomial is one, the general form of which is ax squared plus bx plus c. Now, it has to be written in this form before we can continue. That means the x squared term should come first, then the x term, and then the constant term. Here, the order is slightly changed, so we have to bring it in the standard form first. So we'll just rearrange it a bit so that we get 6x squared minus 7x minus 3. And because we have to find the zeros of the polynomial, we'll have to equate it to 0. Now again, like the process that I told you, we are looking at the product of A and C. So A, again, let's identify A in this case is 6, B is negative 7, and C is negative 3. So A into C, which means 6 into 3 is going to give us 18. So we are going to find factors of 18, two factor products of 18, such that when we subtract the two factors, because here again we've got a negative sign here, so when we subtract those two factors, we should get an answer equal to B, which is 7. So 18, the factors of 18, what can be written as a factor product? So basically one factor product could be 18 times 1. But if we subtract 18 and 1, we get 17, and that is not equal to 7. So that means we are not looking at this. The next factor product of 18 is that it could also be written as 9 times 2. And when we subtract 2 from 9, or 9 minus 2, we could get 7, and that is what we want. So we can stop here, and these are the two factors that we are looking for. And because we have got a negative sign here, B is negative, that means the greater number has to be negative and the smaller one is positive. So this is negative and this is positive. Now again, let's do the middle term splitting method. So middle term splitting, we are going to write 6x squared, the minus 7x. So instead of minus 7x, we'll write it as the sum of two factors, which is minus 9x plus 2x, and we have got the last term, which is minus 3. Now, taking something as common in the first two terms, we know that we can take 3 as common. We can also take x as common. So taking 3x as common, we are left with 2x in the first term. We are left with minus 3 in the second term. And here nothing can be taken common. So I'm just going to take 1 as common. And we are left with 2x minus 3. Again, in both these terms, I can see that 2x minus 3 is common. So I take 2x minus 3 times, I'm left with 3x here, so 3x, and I'm left with 1 here, so plus 1. Now this should be equal to 0. Again, this should be 0, this should be 0. Now if the product of these two is equal to 0, that means one of them is 0, because we know the product, the property of 0, that the product of two numbers can only be 0 if either one of the numbers is 0 or both the numbers is 0. So that means we get either 2x minus 3 is equal to 0 or 3x plus 1 is equal to 0. Now if we find the value of x, 3 goes to the other side, so we are going to get positive 3. 2 comes below that, so we are going to get one root as 3 over 2, and the second root is, if we find the value of x, 1 goes to the other side, it becomes negative 1. We divide it by 3, it becomes negative 1 by 3. So these are the two roots that we have, 3 over 2 and minus 1 over 3. Now I'm not sure what you got because you haven't left a comment in the chat box, but I'm waiting for your answers. And now the second part of the question is, we have to verify the relationship between the zeros and the coefficients. So if we look at the coefficients, like I said, the sum of the two roots alpha plus beta should be equal to negative b upon a. So let's find out what alpha and plus beta is equal to. So alpha plus beta in this case is going to be 3 over 2 plus minus 1 over 3. Now taking the, or it can also be written as 3 upon 2 minus 1 upon 3. Taking the LCM, we take the LCM as 6. This will have to be multiplied by 3. So we get 3 times 3, which is 9. And this has to be multiplied by 2. So that is, we get it as 7 over 6. So the sum of the two roots is 7 over 6. And now we know that should be equal to minus b upon a. So what is minus b upon a? B we know is minus 7. So minus of minus 7, and a is 6. So that also gives us positive 7 upon 6, which means that the sum of the roots is indeed minus b upon a. So that has verified the relationship of the sum of the roots with the coefficients. Now let's look at the product of the roots as well. Product of the roots, so alpha beta should be equal to c over a. Alpha in this case is 3 upon 2 and beta is minus 1 upon 6, 1 upon 3, sorry. So the 3 and 3 get cancelled and we get minus 1 upon 2. Let's find what is c upon a. C upon a, so c is, we know, is minus 3 and a is 6. Again 3 goes into 6 two times, so we get minus 1 upon 2. And since both of these are equal, that means we have verified the relationship between the product of the zeros also with the coefficient. So that's how we verify it. And in case you have any questions, do not forget to leave it in the chat box. And if you're coming to this channel for the first time, I would request you to subscribe to the channel right now so that you do not forget, do not miss out on any notifications that are coming to you of any future videos to be uploaded, and also you get access to all our past videos. Do not forget to like this video also. I'm looking at the maximum likes that you can give, because that only will show you how much love you are giving out to me. And let's move to the next question now. Okay, the next question is that we have to find out, obtain the zeros of the quadratic polynomial. So again, the quadratic polynomial that we have is this. And again, we have to verify the relationship between the zeros and the coefficients. Uh, so let's write the polynomial first. Root 3x square minus 8x plus 4 root 3. Okay, so because we are going to find the roots of the polynomial, that means we'll have to equate it to 0. Let us look at whether it's already in the standard form. So yes, the x square terms comes first, then the x term, and then the constant term. So it is written in the form ax square plus bx plus c. Let's identify what a, b, and c are. So a in this case is root 3, which is the coefficient of x square. B in this case is negative 8. Like I said, it is the coefficient of x. And do not forget to include the sign also before that. And c in this case is 4 root 3. So basically we are looking at the product of a and c. So a multiplied by c, that means root 3 multiplied by 4 root 3 is going to give us 4 into 3, which is 12. So we have to find the factors of 12, two factors, such that we look at this sign. So this is a positive, that means the sum of the two factors should be equal to 12. So should be equal to the middle term, which is 8. Okay, so the first factor product that we have is 12 times 1. So, but if we add the two factors, 12 plus 1 gives us 13, which is not equal to 8. So this is not the factor product that we are looking for. Next, it can also be written as 6 times 2. If we add the two together, we get 6 plus 2 is 8, which is what we are looking for. That means this is what we are going to take. And because we have got negative 8x, that means both of them have to be negative, then only they'll add up to um, negative 8. So let's do the middle term splitting now. So we get root 3x square minus 6x minus 2x plus 4 root 3 is equal to 0. So basically this 8x we have split into two terms. Then we are looking at the product of the two terms in this. So I think I can take root 3 as common. Now 6 can also be written as 2 times 3, and 3 can also be written as root 3 into root 3. So we get 2 root 3 times root 3. So this is also equal to 6. So we can take root 3x as common. We'll be left with x, x here in the first one, and minus, so because we have taken root 3 as common, we'll be left with 2 root 3 in the second term. Then here nothing is common, but I can take minus 1 as common. So when I take minus 1 as common, what I'm left with is, oh, I can also take 2 as common. So when we take minus 2 as common, I'm left with x here. And because I've taken minus outside the bracket, I'll have to change this sign. So this becomes a minus, and 2 we have already taken common. So we are left with 2 root 3 is equal to 0. Now again, x minus 2 root 3 is common in both of them. We take that as common. We'll be left with root 3x over here and minus 2 over here. So that means this is equal to 0. Now if the product of two factors is equal to 0, that means that either one of the factors should be equal to 0. So either x minus 2 root 3 is equal to 0, or we can say that root 3x minus 2 is equal to 0. Okay, then finding the value of x, we get taking 2 root 3 to the other side. So one of the zeros is 2 root 3. And here if we find the value of x, or we take 2 to the other side, so we have got 2 divided by root 3. And again, now we need to find the relationship, verify the relation between the zeros and the coefficients. So let's take, this is alpha and this is beta. So first of all, we know that alpha plus beta should be equal to minus b upon a. So taking alpha plus betas, we get 2 root 3 plus 2 upon root 3. That means we take root 3 as the LCM. This becomes root 3 into root 3 is 3. 3 times 2 is 6. 6 plus 2. So that gives us 8 upon root 3. And let's find out what minus b upon a is equal to now. So minus b means b is minus 8. So that becomes minus of minus 8 over a. A is root 3. So we get 8 upon root 3. And because the LHS is equal to RHS, therefore we have been able to verify the relationship between the sum of the zeros and the coefficients. Let's look at the product of the zeros also. Okay, I've received a message from Bishmesh. Bishmesh, welcome to the stream. Uh, got a little late today, but never mind. And you are saying you have done very good. So next question onwards, do try and find out the roots before I solve it on the screen. So if I get an answer from you before I solve it on the screen, I will consider that you know the subject very, very well. So take care about that and do give me a quick answer from the next question onwards. Let's move to the next part of it. So we are looking at the product of the two roots now, alpha, beta. We know that that should be equal to c upon a. We know that alpha is equal to 2 root 3 and beta is equal to 2 upon root 3. And if we find the product, we can cancel both of them out and we get 4. If we look at c upon a, the RHS now, c we know is 4 root 3 and a is root 3. Again root 3 and root 3 cancel, that also is equal to 4. And because the LHS is equal to RHS, we are able to verify that the product of the roots is also equal to the coefficient c upon a. So usually what it can be written as that we have got we'll have to, if we divide the general polynomial ax squared plus bx plus c, let's say it has roots alpha and beta. So if we divide by a, we get x squared plus b upon a times x plus c upon a. That means this term is actually the negative of this term is the sum of the roots. So we can write it as x squared plus sorry, this will become minus because we are taking the negative of that. So minus alpha plus beta times x plus the product of the two roots, which is c upon a, so alpha beta. So it can also be written like this. So this is just a generally that we are doing. Okay, now let's move to the next question and I need the answers before I can solve it. Again, this is a multiple choice question, should not be very difficult for you, but we are also, I'm going to solve it for you on the screen. But before I give you the answers, you should give me an answer in the chat box and do it carefully, do it quickly also, but carefully also. Be quick enough so that you give the answer before I do it on the screen, but also be sure that you do it correctly. So we need to find the zeros. Now, since we have already learned about the product of the zeros and the sum of the zeros, now we say that, okay, the product of the zeros, okay, in this case, I think we can just take it as, so basically we know that alpha plus beta is minus b upon a. So minus of minus 11 by 3 divided by 7, so that gives us minus 11 by 21. And we know alpha beta is equal to c upon a, so which in this case is minus 2 upon 3 divided by 7, or 7 goes in the denominator, so this becomes minus 2 upon 21. So now we can take the value of alpha as anything. So if alpha beta is minus 2 upon 21, we can say that beta will be equal to minus 2 upon 21 alpha. So putting that value of that in that, so it will become, actually it will become more complicated if we do like this. So instead of doing it like this using the product, the coefficients, the sum of the roots and the coefficients, let's do it another way. Just a minute. Mhm. Let me erase all of it. Okay, let's start it again where we are going to look at a and c. So a multiplied by c gives us, or what we can do is we can multiply it by 3. So get rid of the factor, the fractions first. So multiply the whole thing by 3. So we've got 7x squared minus 11 by 3x minus 2 upon 3. It will make our job easier. Multiply by 3 on both sides of the equation. So we get 21x square minus 11x minus 2 is equal to 0. Then we are looking at the product of A and B. So 21 times 2 is 42. And we have got this negative sign. So negative sign means we are looking at two factor product such that the difference between those two should give us 11. So one of the factors product is 42 times 1. If we find the difference between these two, we get 41. So this is not what we are looking for. Then 42 can also be written as 21 times 2. If we find the difference between two, we get 19, which is not equal to 11. So this is also not what we are looking for. Then it can also be written as 14 times 3. And if we find out the difference between these two, we get 11. And this is what we want. And because we have got negative 11x, that means the bigger number has to be negative and the smaller has to be positive. So this has to be negative, this has to be positive. Let us do the middle term splitting now. So middle term splitting, 21x square minus 14x plus 3x minus 2 is equal to 0. Taking something as common in the first two terms, we know we can take 7x as common. We'll be left with 3x minus 2. And here nothing is common, so we can just take plus 1 as common. And we are left with 3x minus 2 is equal to 0. Now 3x minus 2 is common in both of them. Take that as common. We'll be left with 7x here and minus 2 here. Sorry, 7x plus 1. My mistake. Okay, so that should be equal to 0, which means either 3x minus 2 is equal to 0 or 7x plus 1 is equal to 0. Now obviously if we find the value of x, 2 goes to the other side, becomes positive, 3 is being divided by it, or we can say in this case x will be equal to 1 goes to the other side, becomes negative, divided by 7. So the two roots are 2 by 3 and minus 1 upon 7. So obviously A is the correct answer. Okay, have I got any responses? No, not yet. Okay, let's move to the next question that we have. Find the quadratic polynomial sum and product of whose zeros is minus 1 and minus 20 respectively. Also find the zeros of the polynomial so obtained. Okay, so sum, and here we are given alpha plus beta and we are given alpha beta. So alpha plus beta is equal to minus 1 and alpha beta is equal to minus 20. And we have to find the zeros. So here they have not given us the polynomial, they have not given us what the zeros are, but they have given us the relationship of the zeros, the sum and the product. So we know that ax square plus bx plus c, as I told you, if we divide by a, we get x square plus b upon a times x plus c upon a. Negative b upon a we know is the sum of zeros, so x square minus alpha plus beta times x plus c upon a, or I can write it as alpha beta. So that is equal to that should be equal to c upon a. Okay, so this is the polynomial that I have. So all I have to do is substitute the values. So basically what we are doing is x square minus the sum of the two zeros is minus 1 times x plus c, which is the product of the two zeros, which is given as minus 20. So again, simplifying, opening the brackets, we get x square plus x minus 20. So this is the polynomial that we have. And once we have the polynomial, we are just going to find the factors. So factorize the polynomial. So again, we are going to equate it to 0. We are going to look at a multiplied by c, which in this case is 1 multiplied by 20. So we are going to find the factors of 20 such that the difference between the two factors is equal to the middle term, which is equal to 1. So we are having a look at 20 times 1, if we find the difference between the two, we get 19. This is not what we are looking for. We can also do it as 10 times 2. The difference between the two is 8, which is not equal to 1. This is also not we are looking for. We can have it as 5 times 4, which is also 20. And the difference between the two is 1, which is what we are looking for. So again, it is a positive x. So that means the bigger number has to be positive and the smaller one negative. So let's do the middle term splitting. X square plus 5x minus 4x minus 20 is equal to 0. So I can take x as common. I'll be left with x plus 5 here, and I can take minus 4 as common here, and again I'll be left with x plus 5, that is equal to 0. Here we can take x plus 5 common in both the terms. The second factor will be x minus 4, that is equal to 0. So that means if we multiply the two together, so that means if the product of the two is equal to 0, then that means at least one of them has to be 0, or probably both will be 0. Okay, I've already come up with an answer from one of the students. Bhishmesh says that one of the roots is -5 and the other one is +4. Okay, let's have a look whether we do get that or not. Very good, Bhishmesh. I'm very happy with you. So let's equate both to 0. So x plus 5 is equal to 0, or x minus 4 is equal to 0. So we take 5 to the other side, we get x is equal to -5 or x is equal to 4. And that is indeed the correct answer. Bhishmesh, like he said, -5 and 4 positive. So both of them are correct. Very good, Bhishmesh. And let's move to the next question. So this is the kind of participation that I'm looking for, so that you give me the answers before I am able to solve it. Very good, Bhishmesh. I'm very happy. Let's move to the next question. If the product of the zeros of the polynomial ax square minus 6x minus 6 is 4, find the value of a. Okay, so how do we do this? So here we are given the product of the zeros is 4. We have the polynomial as ax square minus 6x minus 6. Okay, if we find out the relationship between the roots, so we know that alpha plus beta is equal to minus b upon a, and we know that alpha beta is equal to c upon a in this case is equal to a because the coefficient is a only. B in this case is -6, and c in this case is also -6. So we know that alpha plus beta should then be equal to minus of -6 upon a, which is equal to 6 upon a, and we know that alpha beta, which is the product of the two, is equal to c upon a. C is -6 upon a. So the product is the sum of the two zeros is 6 upon a. The product of the two zeros is -6 upon a. But we are also given that alpha beta is also equal to 4. So we can just write that 4 is equal to -6 upon a. And because we have to find the value of a, do we have any correct answers as yet? No, not yet. So because I'm on the verge of solving it, no correct answers. I'm going to give you the answer now. So a goes to the other side, 4 comes below that. So a is equal to -6 upon 4. Bringing it to the lowest terms, we can divide by 2. So we are left with 3 here, 2 here. So that is equal to -3 upon 2. So the value of a is -3 upon 2. Okay, let's move to the next question. Find a quadratic polynomial whose zeros are 1 and -3. Verify the relationship between the coefficient and zeros of the polynomial. Okay, so we are given the zeros here. That means we can say that x is equal to 1. So here we are not given the polynomial. We have to find the polynomial whose zeros are given. earlier we were doing, we had a polynomial of which we found the zeros, but here the zeros are given, so we'll go backward. So it's the same process, but instead of going from the polynomial to the zeros, we'll go backwards from the zeros to the polynomial. So we know that x is equal to 1, and or x is equal to minus 3. Now bringing 1 to the other side, so we get x minus 1 equal to 0, or x plus 3 is equal to 0, because when minus 3 goes there it becomes positive. Now we know that the polynomial should be equal to 0, and it should be a factor, or it should be a product of two factors, and because these are the roots, that means these both are the factors. So we can say that the product of these two should be equal to 0, which means either one of them is 0, or this one is 0, or both of them are 0. Then we can just multiply it, so we can get x square. uh, so basically multiply this by this and then this by this, so x square plus 3x, then multiply -1 by this and by this, so minus x minus 3 is equal to 0. Simplify these two, we get x square plus 2x minus 3 is equal to 0. So this is the polynomial that we have. So the zeros were given, we have found out what the polynomial is. So this is how you have to do it. We are going very quickly now. 1 hour of the stream is already over, and we'll move on to the next question, so that we move a little quickly and we can finish the stream in about 1.5 hours or so. Another 30 minutes left. uh, so okay, a quadratic polynomial whose zeros are 3 upon 5 and -1 upon 2 is this. So basically the zeros are given, so we can do it two ways. One is that we can do it just like the question that we had done here, that in this question we found the two factors, multiplied the two factors, and then found the product. Or the other way is that we can find the alpha plus beta, and we can also find alpha beta. So alpha plus beta will be 3 upon 5 minus 1 upon 2, which means we have got an LCM of 10. We'll multiply this by 2, 6, minus we'll multiply this by 5, so we get 1 upon 10. So alpha plus beta is 1 upon 10, and alpha beta will be 3 upon 5 into minus 1 upon 2. So that gives us minus 3 upon 10. So alpha beta is minus 3 upon 10. And we know that the polynomial can be written as x square minus alpha plus beta times x plus alpha beta. So we can just write it as x square minus alpha plus beta is 1 upon 10 x plus alpha beta. Alpha beta is minus 3 upon 10, so we get minus 3 upon 10 is equal to 0. We don't need to write the zeros. Now to get rid of the fractions, we can multiply the whole thing by 10, so we get 10x square minus x minus 3. That is the polynomial that we have. So which one is the correct option? Any answers? We've got answer from Bhishmesh, who says option 2. Bhishmesh, option 2. There is a slight mistake in the sign, so it should be negative the sum of the zeros. So the sum of the zeros is 1 upon 10. So negative of that is minus. So this will become minus. So option number 4 is the correct option. Right, so be careful about the signs whenever you're doing the questions. Otherwise you are doing a very good job. I'm quite happy with your participation that you're showing. Thank you, Bishmesh. Okay, let's move on to the next question that we have. If alpha beta are the zeros of the quadratic polynomial, find the value of alpha to the power 4 beta square plus alpha square beta to the power 4. Okay, so we don't know what alpha and beta are. So that means there are again two ways of approaching the question. We've got x square minus 4x plus 3. Because we need to find the zeros, we'll have to equate it to 0. and then factorize this and find out what the zeros are. Therefore we get the value of alpha also, we get the value of beta also, and then we can find what alpha to the power 4 beta square plus alpha square beta to the power 4 is equal to. The other way of doing it, that I can also write this polynomial. So if the this is the equation that we have, that means alpha plus beta we know is negative b upon a. So negative b is minus of minus 4 upon 1, which is equal to 4, and alpha beta is c upon a, which is 3 upon 1 or only 3. So we know that alpha beta we already know, so there is no problem with that. We can straight away find the answer of alpha to the power 4 beta square plus alpha square beta to the power 4. Okay, so we can probably taking something as common, we can take alpha square beta square as common, and inside the brackets we'll be left with, sorry, not equal to here. So we are just taking it as common, and inside the brackets we'll be left with alpha square plus beta square. Now we know what the value of alpha beta is, and therefore we know that alpha square beta square would be actually nothing but 3 square, which will be equal to 9. But we don't know what alpha square plus beta square is. But we know that alpha plus beta is equal to 4. What if we square the two sides? So alpha plus beta whole square would be equal to 4 square. So that gives us alpha square plus beta square plus 2 alpha beta is equal to 16. Now alpha beta we know already know as 3. So this becomes alpha square plus beta square plus 2 times 3, which is equal to 6, would be equal to 16. Now 6 goes to the other side, therefore alpha square plus beta square is equal to 16 minus 6, which is equal to 10. So we have found the value. So alpha square beta square is 9, and multiplied by alpha square plus beta square we found it to be 10. So 9 multiplied by 10 is 90. That's how simple it is. Okay, Bishmesh has written square will be taken common. Yes, you are absolutely right. We did take the squares as common, and yes, and that's how we approach the question. So even though it looked a little tricky, but it actually turned out to be a very simple question. So that's how, if we approach it in the right manner, we'll able to solve the question in a jiffy. Okay, I've got a pen in hand, so can't do like this, but okay, we can solve it in a jiffy. Okay, let's go to the next one. Okay, Bishmesh, ready to take the next question? Okay, we have to find the value of k such that the polynomial x square, let me write the polynomial again, x square minus k plus 6 times x plus 2 times 2k minus 1 has sum of its zeros equal to half of their product. That means sum of the two zeros alpha plus beta, if the two zeros are alpha and beta, then the sum of the two zeros alpha plus beta is equal to half their product. So it means it should be equal to alpha beta divided by 2. So this is what we are given. Okay, now from the polynomial we can find that uh, alpha plus beta is equal to minus b upon a. We know the relationship of the coefficients, and we know that alpha beta is equal to c upon a. A happens to be 1 here, so that means we can just ignore the 1. So alpha plus beta is actually minus of minus k plus 6, which is nothing but positive k plus 6. So that is alpha plus beta, and alpha beta would then be equal to 2 times 2k minus 1. So then all we have to do is that we are already given this thing over here, that alpha plus beta is equal to half of their product. So I'm taking the right hand side first. So alpha 2 times the product of the two zeros, 2 times 2k minus 1 divided by 2. I'm putting it in this equation. So if this equation is equation number 1, I'm putting these values of alpha plus beta and alpha beta into that equation. So we get 2 times 2k minus 1 divided by 2. That should be equal to alpha plus beta, which we know is k plus 6. Here the 2 and 2 can get cancelled. Bishmesh, have you found out the value of k? Okay, Bishmesh is saying the value is 2. Let's see what the value is. Okay, so we have got 2k minus 1 is equal to k plus 6. I don't think it is 2. I don't think it is 2 because k will go to the other side. So we get 2k minus k and minus 1 will go to the other side. So that should be equal to 6 plus 1. So 2k minus k is k and 6 plus 1 is 7. So actually k should be equal to 7. That's the correct answer. Okay, now you have corrected it. That answer is 7. Very good. Okay, let's move on to the next question. Next question, how many questions are we left with? Okay, I think we are left with 6 more questions. Okay, uh, right. I think we are on time. We should be able to finish it by 1.5 hours. So by 6:30, that's our target. We should plan to close 6:30 or 6:45. But again, I'm sure you people must have already subscribed to the channel. If you have not subscribed, do subscribe to it right now so that you get access to all our past videos, and also you are able to get a notification of whenever our future video is released. But for that it is very necessary that you all click on the bell notification also, and so that you get a notification. So click the bell notification, click on all, and then you will get the notification that a video has been uploaded. You can also follow our channel or subscribe to my second channel, which is Ganitavya. The live streams are held alternately on both weeks here. Okay, and next we take it as okay, let's move to the next question. And do not forget to like this video also. Show me some love. I will like it if you do like the video. Okay, the next question that we have is find the zeros of the polynomial 2 root 3 x square. Let me write it again. 2 root 3 x square minus 5x plus root 3, and verify the relationship between the zeros and the coefficients. So here we will have to find the zeros, and to find the zeros, let me equate it to 0. We know that a is equal to 2 root 3, b is equal to negative 5, and c is equal to root 3. We are looking at the product of a and c, which is equal to 2 root 3 times root 3. Root 3 times root 3 is 3, and 3 times 2 is 6. So we are looking at the factors of 6 such that when we going to add or subtract. So we've got a positive sign here. That means we should add the two factors and we should get it equal to 5. So if one of the factor products is 6 into 1, if we add both of them, 6 plus 1 is equal to 7. So this is obviously not we are looking for. 6 can also be written as 3 times 2, and if we add 3 and 2, we get 5, and this is what we are looking for because our middle term is also minus 5. And because it is minus 5, that means both of them have to be minus, then only we'll get it as minus 5. So then we can do the middle term splitting. रूट्स जल्दी से निकाल लो, जो भी ऑनलाइन है, फाइंड आउट द रूट्स क्विकली and let me know in the comment box right away, chat box. Okay, meanwhile I'll do the middle term splitting. So I've got 2 root 3 x square minus 5x. I'm going to write it as minus 3x minus 2x plus root 3 is equal to 0. Now again, because we have got root 3 and 3, I can take root 3x as common in both of them. So I'll be left with 2x here in the first term, I'll be left with root 3 in the second term. Here we have got nothing common. I can take minus 1 as common though, and I'll be left with 2x minus root 3 is equal to 0. Again, 2x minus root 3 is common. Do we have any correct answers? Zeros are root 3 and 1 by 2 root 3. Okay, let me see what the roots are. So that means uh, 2x minus root 3, taking it as common, we are left with root 3x minus 1 is equal to 0, which means either 2x minus root 3 is equal to 0, or we can say that root 3x minus 1 is equal to 0. Then finding the value of x, root 3 goes to the other side, so root 3 upon 2, or in this case, we get 1 goes to the other side, 1 over root 3. Hmm. Root 3, zeros are root 3 and 1 by 2 root 3. कुछ उल्टा कर दिया बीच में जी. It should be root 3 upon 2 and 1 upon root 3. मैंने तो नहीं कुछ गलती की. 2x minus root 3. That is correct. So it has to be root 3 upon 2 and 1 over root 3. Okay, गलत कर दिया ना आपने. Okay, never mind. Do it carefully and let's move to the next question. The next question that we have is uh, ये कौन सा स्माइली है सर आपने सही किया है ओके थैंक यू आई हैव डन इट करेक्टली आपने ही कुछ गलती कर दी थी बट नेवर माइंड होता है कई बार जल्दी जल्दी करते हैं तो गलती हो जाती है बट ट्राई एंड डू इट केयरफुली सो बिकॉज आवर पर्पस इज to do it not only to do it quickly but also to get the right answer so accuracy as well as speed is very important okay and middle term mein you took 6 ओके मिडिल टर्म में आपने 6 लिया था लेट्स सी व्हाट इज द मिडिल टर्म में आपने ओके आपने 6 और 1 ले लिया होगा ना दैट मस्ट हैव बीन वेयर यू गॉट रॉन्ग हाँ क्योंकि पता है दिस इज व्हाट आई वांटेड टू एक्सप्लेन कि अब यहाँ पे अगर हम देखें 3 + 2 इज ऑल्सो 5 एंड 6 - 1 इज ऑल्सो इक्वल टू 5 तो अब दोनों ही 5 के इक्वल आ रहे हैं तो अब हमको कौन सा वाला लेना चाहिए दैट इज वाई दिस साइन बिफोर दैट इज इक्वल तो जैसे आप देख रहे हैं ना let me write it again so that I don't you don't misunderstand me so 2 root 3 x square minus 5x plus root 3 is equal to 0 so जो constant term से पहले का जो sign है you have to look at that sign the sign before the constant term that is positive a positive means you will have to add the two factors and a negative sign there means you will have to subtract the two factors so 6 into 1 we cannot take because 6 plus 1 is actually 7 so that is where we cannot take that and we have to subtract the two sorry add the two so therefore the only possible option is 3 and 2 got it okay very good so this actually gave me an option to where it actually worked out both ways so it's very easy for students to get confused but not to get confused that is why this taking this sign is very important so a plus means add the two factors and a minus means subtract the two factors to find out which one you should take okay let's move to the next question. So if alpha and beta are the zeros or the polynomial so and so, so let me write the polynomial p of x. Excuse me. P of x should be equal to 2x square plus 5x plus k. Okay. And alpha and beta are the roots. I have already written what is given to me. And the roots are satisfying the equation alpha square plus beta square plus alpha beta is equal to 21 by 4. Okay, we have to find the value of k. How will you do? People online, let me know in the comment box, chat box right now. How will we do this? How will we approach the question? We don't have k, so we cannot find out the roots of this equation because the roots are not given because whenever there is a variable we cannot find the roots. So if the roots are not given and we cannot find the roots also, how will we approach the question? What do you think? There are some people online. I want to see what do you guys think. Waiting for some answers. Okay, no answers yet. I think you people are as confused as I am. I am confused. Probably I would have been confused, but because I know what the answers are, and obviously I don't remember the answers, we are going to solve it together and we'll see what the correct answers are. But I can guess what the approach should be. Can you people guess what the approach should be? Okay, let me give you the answer. So we know that uh, the sum we know that a polynomial can also be written as x square. So a has to be 1 in this case when we take it as sum of roots and product of roots. So x square minus alpha plus beta times x plus alpha beta is equal to 0. So the polynomial can also be written like that. So using this, if we divide the whole equation by 2, we know that p of x will be actually x square plus 5 upon 2x plus k upon 2. That means we know that alpha plus beta is nothing but minus 5 upon 2 and alpha beta is k upon 2. And we know that it also satisfies this relationship. Now, how do we get from this to this? Easy. Okay, Abhay. Welcome to the stream, Abhay. It is very confusing. Yes, it is confusing, but once we know the relationship between the product of the roots and the sum of the roots, it becomes easy. Now, I've given you the hint. Can you think about it right now? How can we do it? How do we get from alpha plus beta is equal to minus 5 upon 2 and alpha beta is equal to k upon 2 to alpha square plus beta square plus alpha beta is equal to 21 upon 4? Any takers? Okay, let me tell you. So if we look at this equation here, what I'm going to do is I'll square both the sides. So squaring both sides, I get alpha square plus beta square plus 2 times alpha beta should be equal to the square of this. So it will become positive. 5 square is 25 and 2 square is 4. So alpha square plus beta square plus 22 alpha beta is equal to 25 by 4. We can also write it like this. Now anybody can solve it. I think it should be easy now. Okay, we can write it like alpha square plus beta square plus alpha beta because 2 alpha beta is nothing. I can split it as alpha beta plus alpha beta. That is equal to 25 upon 4. But we already know from this equation that alpha squared plus beta squared plus alpha beta is nothing but 21 upon 4. That means 21 upon 4 plus alpha beta is equal to 25 upon 4. So therefore the value of alpha beta is equal to 25 upon 4 minus 21 upon 4, which is equal to 25 minus 21 is 4 upon 4, which is equal to 1. So alpha beta is equal to 1. Now we had already written it like this. So that and like this. So that means alpha beta is actually k upon 2. So k upon 2 is equal to alpha beta, which is 1. And taking 2 to the other side, we can say that implies that k is equal to 2. So that is the value of k, right? So even though a question looks tricky, but if we know the relationship between the product of the roots and the sum of the roots and with the coefficients, we can easily find. We couldn't have found out the roots of this equation because k was unknown. So without finding the roots, just by using the relationship between the roots and the coefficients, we found the value of k. Right? Let's move to the next question that we have. Again, a multiple type question. Here you don't have to solve anything. It's just a simple question that the zeros of the quadratic polynomial x squared plus 88x plus 125 are both positive, both negative, one positive and one negative, or both are equal. What do you think? Correct answer. Choose the correct answer. Write it in the chat box right now. I'm not going to explain it to you till I get the answer from you guys. Come on, fatafat. Okay, no correct answers. Okay, since you're not able to give me the correct answers, I'll proceed with it. So let me tell you, we know that alpha plus beta, what is this? Okay, alpha plus beta we know is minus b upon a, and alpha beta we know is c upon a. Now if think about it, if one of them is positive and the other one is negative, so we have got two roots. The possibilities are that both are positive, alpha is negative, beta is positive, or alpha is positive, beta is negative, and both are negative. So these are the four possibilities that we have. What will happen to alpha beta in this case? So if both are positive, alpha beta will be positive. If one is negative and one is positive, both are going to be the alpha beta is going to be negative. If this one is positive, this one is negative, again alpha beta is going to be negative. And if both are negative, alpha beta is going to be positive. So that means because we have got alpha beta is equal to c upon a, in which case this in this case it will be 125 upon 1 or only 125, which means it is positive. And before, because alpha beta is positive, that means that it should be these two options only, either both are positive or both are negative. So one positive and one negative is cancelled. Okay, let's look at the next question. Now to for it to be equal, we have to we get equal roots only if it's the form a plus b whole square. So in that case, we see that the third term 125 is not a perfect square. So therefore both roots cannot be equal. So this option is also gone. We are left with two possibilities now. Either both should be positive or both should be negative. Abhay says that both should be positive. Okay, let's see. Uh, okay, so we've got x square plus 88x plus 125. We also know that it can be written as x square minus alpha plus beta times x plus alpha beta. Now, alpha beta we know is positive, so that is 125. Uh, the sum of the roots is equal to 88. Actually, the negative of b upon a is equal to 88. B we in this case we know is positive 88. So b so b negative b upon a, using this we get is negative 88 upon 1, which is negative 88. That means if we had a negative 88 over here, then both of them would have been negative. But because we have got a positive term here, therefore both roots have to be positive. Then only. Now think about it. When you're adding the two roots, both will, so minus alpha plus beta. So if negative of a negative, so if alpha plus beta is negative, then minus and minus will become plus 88, right? So alpha and beta both have to be negative. We are sure that both are either negative or both are positive. But alpha and beta as a whole should be negative, then only it will become plus 88x. Therefore, we can say that in this case both should be negative, because the sum of the two roots will become negative and the negative of the sum of the roots will give us a positive 88. Got it? Okay. Very good, all the people. Let's move to the next question. Oh, we are already out of time. 6:30 ho gaya. Let's finish it fast. How many? Three questions more. Okay. If x plus a is a factor of this, then find the value of a. Okay. So the polynomial is 2x square plus 2ax plus 5x plus 10. We have to find the value of a, and we know x plus a is a factor. That means it can be equal to 0. That means we can basically x is equal to minus a. Now this is using the factor theorem, that if x plus a is a factor, that means the factor should be equal to 0, and therefore we can find the value of x. And using the remainder theorem, we know that p of minus a now. So if this is equal to p of x, we'll find p of minus a. So in this case, wherever an x comes, we are going to replace it with minus a. So minus a times square whole square plus 2a times minus a plus 5 times minus a plus 10. That should be equal to 0, because the remainder we know is 0, because x plus a is a factor. Okay. Uh, so what do we get here? We get minus a whole square is a square, so we get 2a square plus uh, 2a times minus a is actually minus 2a square, plus 5 into minus a is minus 5a, plus 10 is equal to 0. 2a square and minus 2a square get cancelled, so we get minus 5a is plus 10 is equal to 0. We can take minus 5a to the other side, so we get 5a should be equal to 10, or a should be equal to 10 over 5, which is equal to 2. Now, in case you don't understand this, people say that we always have to keep the variable on the left hand side and take everything else to the right hand side. Well, you can do whatever way you want, because on one side you should have the variables. It could be the left side, it could be the right side. Because if I say that A is equal to B, I can also say that B is equal to A, right? So that is why I've taken minus 5a to the other side, so that that becomes positive, and straight away we can find the value of a. But we can also do it like this, that we take 10 to the other side. So in that case it will become minus 5a is equal to minus 10, and then to find the value of a we'll have to divide by minus 5. So again, minus and minus get cancelled, and this becomes 2. So any which ways we do, we'll get the value of a as 2 only. Okay, last two questions of the day. I need some participation from you guys. Do it very quickly with me, and we'll finish in 10 minutes. Okay, uh, uh, if 2 by 3 and minus 3 are the zeros, so we let the two zeros be alpha and beta. So alpha is equal to 2 by 3 and beta is equal to minus 3 are the zeros of the polynomial. So let me take the polynomial p of x is equal to ax square plus 7x plus b. Then find the values of a and b. Okay, so again this is a question relating to the sum and product of the relationship between the sum of the zeros and the coefficients, and the product of the zeros and the coefficients. So we can also write this polynomial as uh, a, sorry, I every time I write a. So whenever you're writing it as sum of the products and product of the products, product of the roots, so you'll have to take a as 1. So it will be x square minus alpha plus beta times x plus alpha beta. So using both of these together, we can see that alpha plus beta is actually minus b upon a. In this case, we have got a as a, b as 7, and c as b. Okay, so minus b upon a from this will be minus 7 upon a, right? Okay, so the product, the sum of the roots is equal to minus 7 upon a. So this is simple, and we also know that alpha beta is equal to c upon a. So using this, c is equal to b and a is equal to a. So the sum of the product of the root should be equal to b upon a. Okay, let's put the first thing. The first thing, the alpha plus beta is minus 7 upon a, but we know that the two roots are given to us. So what we can find is, we can find alpha plus beta as 2 by 3 plus minus 3 also, and similarly alpha beta we can also find it as 2 upon 3 multiplied by minus 3. So let us find this. 3 becomes the LCM. This will become 2 plus, no, it will become a negative and multiplied by 3. So it will become minus 9 is equal to minus 7 upon 3. And alpha beta will be equal to 3 and 3 gets cancelled. So alpha beta will be minus 2. So again, equating the two, we can straight away see that minus 7 by a is equal to minus 7 upon 3. Minus 7 and minus 7 can get cancelled. So 1 upon a is equal to 1 upon 3. Taking the reciprocals, we can say a is equal to 3. So we have found the value of a. Now we know that if now the same way we can find the value of b. So we know that alpha beta, from this equation, alpha beta is equal to b upon a, which is also equal to minus 2. So b upon a is equal to minus 2. A we know is equal to 3. We have already found that. So b upon 3 should be equal to minus 2. Taking 3 to the other side, we get b is equal to minus 6. So a is equal to 3, b is equal to minus 6. Any right answers? No right answers. Okay, last question of the day, and it's a multiple type question. And quickly tell me the answer. Which one should be the correct answer? If one zero of the polynomial 3x square plus 8x plus k is the reciprocal of the other, then k is equal to what? Okay, simple question. Quickly tell me whether k is 1, sorry, there's no 1. Whether k is 3, it should be minus 3, it should be 1 upon 3, or minus 1 upon 3. Come on. Sum of the roots, product of the roots. Think about the relationship between the coefficients and the roots. We can write the polynomial as x square minus alpha plus beta times x plus alpha beta, and we are given that 1 0 is the reciprocal of the other. So if alpha is one root, then the other root has to be 1 upon alpha. The product of the two roots will be, the sum of the two roots should be alpha plus 1 upon alpha, whatever that is. The product of the root should be alpha into 1 upon alpha. This is easier to find. Alpha and alpha get cancelled, so that means 1. That means the product of the roots alpha beta is equal to 1, and alpha beta we also know is equal to c upon a. In this polynomial 3x square plus 8x plus k, a is equal to 3, b is equal to 8, and c is equal to k. That means c upon a is equal to 1. C upon a is equal to 1. And using this, c upon a will be k upon 3 is equal to 1. Therefore, k will be equal to 3. So obviously the first option is the correct option. Abe Badoria, this no, this is the answer to your old question. Okay. So no correct answers from anyone, and this was the last question of the day. And yes, we are arrived to the end of the live stream now. So it's now just me, and let's forget about what we had. I hope you understood something out of it. Now, all the questions, like I said, I chose which I think were important from the board's point of view. These are very, very likely to come in the board exam. And because your first session is going to be a multiple choice question, that is why I have chosen a lot of multiple choice MCQ type questions also, so that you get used to the concept. Okay, so now that we have covered it, in our next live stream we are going to cover the relationship of the roots and the sum of the roots and the product of the roots with the coefficients of the polynomial. But we are not going to be looking at quadratic polynomials in the next live stream. We'll be looking at cubic polynomials and quartic polynomials, or quartic polynomials are also known as biquadratic polynomials. So we'll be looking at both of them together, cubic and biquadratic. We'll do it in the next live stream. But because we are going to do it on the other channel, therefore you have to be very careful that you subscribe to my other channel also, which is by the name of Ganitavya. So just go to YouTube, search for Ganitavya. You will find a channel with my picture, like something like this. You will find a picture like that, and just subscribe to that channel. Because and do not forget to click on the bell notification, because that will make sure that whenever a video is uploaded, you will get it right into your inbox. You will get a notification, or whenever a live stream is scheduled, you'll get a notification. But as it is, I do all my live streams every Sunday at 5 p.m. Alternate weeks. So one time on Ganitavya, one time on Exponent to Success. So next time it will be on Ganitavya. Do not forget to subscribe to the channel. Do not forget to subscribe to Exponent to Success also right now. And because again, you'll have to click on the bell notification to get the all the notifications, and do not forget to like this video before you leave. And what I'll do is, after the stream ends, I'm going to put a few videos in the description box, so you can check this link later. And I would suggest that you watch those videos also as well. So I haven't put them in the description box as yet, but in some time, probably in about half an hour, you'll be able to see it in the description box. I would suggest that you watch those videos as well to get a better understanding of the concepts that we have covered in class today. Okay, so I'm going to see you next week. And before that, let me show you my intro video again, because that is what I usually start and end with. I don't know if I showed this to you in the beginning. Probably I forgot today, but before you leave, this is my video, intro video to Exponent to Success. So, like it said, exponent to success adds an exponent to your learning curve. So, basically, if you're subscribed to the channel, it will basically your learning curve will go like an exponential graph. So, it will go like this, or how should I go? Go like this. So it starts slowly, and then there is a very steep increase. So exponent to success will add an exponent to your learning curve, so that it becomes steeper by the day, and by the end of the year, I'm sure you will be in a position to top the class. Not only the class, I would even say that you'll be in a position to top the school as well. So whichever city you are from, probably you'll come in the top 10. Or if you are a very good student, if you apply all the concept properly, you can even top your city. So all you have to do is just stay connected with both of my channels and watch the live stream every week, so that by the end of the year we have covered all the topics together, and we'll see what we can do, where we will reach by the end of the year. So wish you all the best. Take care and God bless. See you next week.